Welcome to a lesson with Dr. Powell. Let's take a look at how we can find the polynomial span of a vector, or Rx span of a vector, if we're thinking about x as being the action of a matrix A, a square matrix A. So this is not an R span of a vector. An R span would just simply be all real number multiples of this, but we're going to be taking polynomial multiples of this. So polynomial is acting on this, where the action of x is this matrix A. So for instance, if we look at x squared plus 1, that can act on this vector. In fact, if we look at how it acts on this vector, thinking of x as being this matrix. So when we square, it's like squaring the matrix. And 1 is a scalar. And how does a scalar act? It acts by scalar matrix like this, diagonal here with 1s down the diagonal because this is a 1 here. And so we can think about this acting on V, just as an example, x squared plus 1, acting on V in the following way. We take this matrix, which represents x squared plus 1, and we can plug in 0, 1, 1. And what do we get out? Well, this just simply means you add the last two columns, which is just 0. So this is equal to the 0 vector. Okay, now we can actually use this fact to describe the whole polynomial span of V. Because what we can do is, if we have any polynomial at all acting on V, we can think of this polynomial, if we do a little division with x squared plus 1 dividing into p of x, so there would be a quotient happening times x squared plus 1 plus a remainder. Now notice that now in this case, if we were to act p of x on V, so imagine V coming in and the action will distribute. So that's remainders acting on V, this part's acting on V. But this part acting on V, we know x squared plus 1 acting on V is just 0. So this part right here is gone. And then we're left with this, the remainder acting on V. Now, what kind of polynomials are the remainders? Well, since we're dividing by a degree 2 polynomial, the remainders are up to degree 1. So essentially, all we need to do is be looking at all polynomials up to degree 1, some things like ax plus b. And it suffices, if we're thinking about an R span, that's what these angled brackets mean right here, an R span, to simply consider what x dot v is and 1 dot v. So x acting on v and 1 acting on v, and that'll be enough to give us the whole span. And it all had to do with, if we can find a polynomial that acts like 0, find its degree, and then we just go 1 less, and then we're sure that that's going to be equal to the polynomial span of the vector. So now x acting on v, what does that mean? We just put this vector into this matrix, into our matrix A. So we can think putting in 0, 1, 1 here. We're just going to be adding the last two columns. So naturally, we'll get negative 1, 1. That's what we have there. And then v, of course, is just v there. So we have just computed the polynomial span of a vector v. Thanks for watching.